Hi, friends at the Cincinnati Zoo. I'm Lauren Angeloni from Xavier University, and I'm going to provide you some background on science standards, how kids should be learning science, and how you can help support them through the Project NOAA site to practice more of those types of science practices we want them to be doing in schools. So I have the website for the Next Generation Science Standards up. These are national science standards that were adopted in 2014 based on the framework for K-12 science education. And these really narrow the instruction down to a few topics so that students can really practice thinking and doing the work of scientists rather than focusing on content like was done in the past. So in the Next Generation Science Standards, they focus on these three dimensions, which are the core ideas, the content of the past, physical science, life science, earth science. These cross-cutting concepts are new, which are things like structure and function that go across content area that are highlighted in different ways in instruction. But what we are going to focus on here are helping students develop science practices, or how students can act and think like a scientist. These are called science and engineering practices. We're focusing on the science practices. Now, the Next Generation Science Standards have not been adopted in Ohio, but the Ohio standards have taken the shape of the Next Generation Science Standards. But Ohio didn't adopt them because they didn't want something similar to what happened with Common Core to happen. But they did take many of these components and include them in the new standards. Kentucky has adopted the Next Generation Science Standards, and also Indiana has not. So I'm going to go ahead and click on this More About 3D Learning to show you the practices. So we have Dimension 1, there's some more explanation. And I'm going to show you the 8 practices that we're focusing on. So they're listed right here. We have asking questions for science and defining problems for engineering. So we're working on asking questions, developing and using models, planning and carrying out investigations, analyzing and interpreting data, using math and computational thinking, constructing explanations for science, which is what we're focused on, engaging in argument from evidence, and obtaining, evaluating, and communicating information. Of these 8, I think engaging in argument from evidence is the newest, and it's really where we're having students practicing agreeing or disagreeing with the conclusions that other scientists in their class make to better represent the process of science and how a theory becomes a solid theory through that conference process where people come together, scientists come together, share their data, and sort of hash it out. So we're really helping students to think through that process. I've also made this document that I sent to you to help you with some suggestions for each practice, the types of questions that you might ask students to model the practice or to push them to engage with the practice. And I'm going to show you some examples within Project NOAA as well. So let me start actually with Project NOAA, and we'll go back to that document. So here's a Project NOAA example of a spotting. This is from an elementary school that we worked with in the past. So this is what they call a mosquito. And you can see that each student will write a description of the animal. They will write about their habitat, and then they have a space to write notes. And so we've given them suggestions for what to do in each of those spots. And then you can see there's an ID suggestion. So another scientist has come in and suggested that this is actually a wood gnat, and then others can +1 and agree if there are multiple identification suggestions. So that might be a feature you'll use. I'll show you back in the document to support argumentation, practice 7. So here's where you'll be writing comments on the students' spottings. And so here's sort of typical responses. Here's one from a scientist, and the scientist says, this small fly is a non-biting fly. It is called a wood gnat. They like to feed on decaying wood and vegetation and fermenting sap. I can see why you might be confused about what type of fly, since they do somewhat resemble mosquitoes. Very cool find. I have never seen one of these before. So the scientist comes in and tells the student what it actually is. And they very nicely say why they think they would be confused. We think that it could be a little bit better. There could be some questioning involved, and some, practicing those practices together, rather than simply correcting. Now, here's another scientist. I agree, it's not a mosquito. And then we have from the school several other students commenting, and you'll see these are kind of typical types of comments from others on Project Noah. Awesome. It's on his leg, and I don't know if he got bitten. This is a really good picture. Nice find. Did you know only female mosquitoes bite? Don't you dare get bitten. A lot of cools, a lot of comments on photography. Here again is the scientist. They must have said this at the beginning. Neat find. This is a fly, but not a mosquito. Okay. So that's what it looks like when students and a scientist comment on a find. Now here's another one on a very interesting looking gray squirrel. You can see here too, we see on the map it was found in the Niagara Falls region. Now this is from somebody who has this ranger badge, which means that they're certified through Project Noah, that they are a scientist with some expertise in these spottings. So you can see here they have the description, the habitat, and the notes. No one suggested an ID because they must agree with him. But a lot of people here, even, these are adults, are saying amazing spotting. His color is astonishing. He responds here. Nice pick, lovely animal, very beautiful. So these are the sorts of comments that are here. Once in a while, there's a question. This is one just about sharing on Twitter. But there is one on melanism down here a little further. Oh, look, it's forest dragon again. This is a pretty amazing color morph. There's an oddly colored morph here in my neighborhood, but I haven't been able to spot that darn squirrel since I saw it the first time. The squirrel in the link looks like it's shedding fur for a new coat. Old black fur coats on living animals can blanch to brown. So you can see then there's some discussion here. What color is the one you saw? And you see more scientific discussion here between these two scientists about the strange color of this squirrel. One thing I want you to notice about Project Noah that I wish was better is that there aren't threaded discussions. So they really have to just say each other's name when they're having a discussion because all comments just go under one thread. So then you see some awesome, nice series. They respond thanks to that particular person since they can't do a threaded discussion. So what we're hoping that you'll do is sort of support these more scientific types of discussions with the students that are posting on Project Noah for our particular project, rather than maybe just correcting or just saying, wow, that's really cool. So we want to support their science practices as much as possible. So here I have this document that I'm sharing with you with some ideas. So practice 1 is really on asking questions. At the lowest level, you can ask questions just for more information. Students should be doing that at the K2 level. And then it's pushed further to asking questions that can be answered by an investigation. So pushing them maybe even to further investigations. So here's an example. It is so interesting that this plant with such beautiful flowers didn't have any pollinators visit it. Could you try observing your plant at a different time of day, like early in the morning, to see if you find pollinators then? So here you can see you're kind of pushing them to think of a new investigable question, rather than just telling them that, maybe they should try another time of day, or, oh, that's too bad, you didn't have any pollinators. So this is really pushing them to think further and do some more work. The second practice is developing and using models. And this is using, at the lowest level, simple models, drawings to scale, showing patterns and relationships. In older grades, they should be able to revise models based on new evidence, and then use models to predict. In this particular project, I'm not sure there's a great chance for this, especially since we're posting to Project Noah, where you should post your organism and a description. So you're not really posting any models that you might draw. There might be some modeling discussion perhaps in the notes. So really, if you have ideas to this, I'm open to hearing them too. So I'm opening this up for ideas. I'm not sure this one is supported, and that just might not be that this project particularly supports modeling. I had one idea. If you saw a bee for 3 days at noon on your plant, what do you predict will happen on the 4th day? So maybe building this model for, patterns that the bees have for what time they come and visit, for example, but I think it's a little bit of a stretch. The third practice is planning and carrying out investigations. So we want students to be able to create a plan and conduct an investigation and to gather evidence to serve as a basis for their explanations later on. In older grades, they should evaluate appropriate methods and or tools for collecting data. So this investigation is really planned out with them, as you'll see in the lesson plan. So they won't have the chance to plan unless you ask them those further questions to push them maybe further in their investigations. So some suggestions here are, I see that you think your plant is good for attracting pollinators. What pollinators did you observe that made you think that? So just asking them, if they don't give evidence, to push and make sure that they're providing evidence. You observed your plant every day for 10 minutes. What do you think might change if you observed your plant for longer? So again, asking them questions to maybe further their investigation and make it a little bit better. Practice 4 is analyzing and interpreting data. So we want them to, at the base level, be recording information and using and sharing pictures, drawings, writings. They have a chart in their lesson plan that you've seen, but they won't be able to show this on Project Noah because of the format. But we also want them to use the observations to describe patterns or relationships. So supporting that will also be helpful in supporting their science practices. So for example, you had a lot of beetles visit your plant on the first day, but not the second and third. Why do you think that happened? Did anything else change? That's too bad you didn't get to observe pollinators on your plants. If you take a look at the other spottings in this mission, you might see that there are a lot of pollinators spotted on the flowers of the plants. It looks like your plant will flower in July. What do you think might change if you observed your plant? So this is opening them up to the bigger investigation to look at others for patterns and relationships, and also to consider their own, research that their plant doesn't flower till July. Practice 5 is using mathematics and computational thinking. So this is deciding what types of data, if they need a quantitative type of data or qualitative, and then organizing simple data sets. So again, with patterns, this overlaps quite a bit with patterns and relationships. When your plant flowered on day 2, how many more pollinators did you observe? Why do you think that is? So maybe pushing some of their findings a little bit more deeply. And then practice 6 is constructing explanations. So they're making now a claim about what they think is happening. So making observations to construct an evidence-based account or a claim for this natural phenomena. And then to construct an explanation of observed relationship is for the older grades. So here's an example. I see that your claim is that your plant is good at attracting pollinators because you had several types of pollinators visited each day. Do you think that variety or the number of pollinators is more important? So again, their claim was logical, but just pushing their thinking more. Practice 7, this is the one that I said was a little bit newer. This is engaging in argument from evidence, helping students model that kind of collective knowledge building practice of scientists all over the world. So constructing an argument with evidence to support their claim and distinguishing between opinions and evidence, and then also respectfully providing critiques. So you can model here how to kind of disagree with the students, tell them to maybe reach for more information to be able to make those claims, or maybe they have to go back to the research to understand a little bit better. So here are some examples. I see that you claim that this plant is a dandelion and that the dandelion is good at attracting pollinators because you saw several bees visit your dandelion each day. I agree with your conclusion, but I'm not sure if your plant is a dandelion. Its flower is wider than dandelions I've seen. Could you measure and tell us how big the flower is? This is also an appropriate place to use that suggest an ID feature right here. So you can suggest, but again, I would say, ask them some questions to see if they could change their mind first. and then use that suggest an ID feature.